You know, one of the biggest revolutions happening in medicine right now is being powered by artificial intelligence. But how in the world did we get here? Well, in this explainer, we're going to break down the key forces that are making all of this possible, right now.
It's a really good question, right? I mean, we've all seen AI finish our sentences in an email. But how does that same basic idea make the incredible leap to something as high stakes as reading a medical scan? It feels like a massive jump, and, well, it is. So the secret here isn't one single aha moment or invention. Nope. Modern medical AI is really the result of a perfect storm, a convergence of three incredibly powerful forces all hitting at the same time. A total flood of clinical data, a revolution in computing power, and of course, way smarter AI models.
Okay, let's start with the first and maybe the most important ingredient, data. Because with any AI, it's pretty simple. The better your ingredients, the better the final dish. And in healthcare, we've gone from a data desert to a data ocean, almost overnight.
And the scale of this change is just staggering. Seriously, think about it. Not that long ago, your entire medical history was a big, thick stack of paper shoved in a file cabinet somewhere. It was basically locked away, impossible to search, and you could get very little insight from it. The move to digital, it's been a complete and total game changer. And as you can see, this didn't just happen all at once. Back in the 2000s, electronic health records, EHRs, started to take over from paper. Then the 2010s brought this explosion in super high-resolution imaging. And now, we're swimming in real-time data from our smartwatches and from genomic sequencing. Every single wave just added another rich layer of information for AI to learn from.
And look, this isn't just about collecting data for the sake of it. It's about getting a live, constantly updating picture of a person's health. This kind of nonstop monitoring can power predictive models that spot trouble long before it ever becomes a full-blown emergency.
So we've got all this amazing data, but that's only half the story, right? I mean, having a library with every book ever written doesn't do you any good if you can't actually read them. You need the horsepower to process all of that information. And the breakthrough for that came from a place nobody expected: video games. Seriously. Graphical processing units, or GPUs, were built to render amazing 3D worlds by doing millions of calculations all at once. Well, it turns out that exact same parallel processing was the perfect recipe for training giant AI models. This discovery literally changed the entire path of AI development. Before GPUs became the standard for AI research, trying to train a really complex model on a huge medical dataset was, well, it was almost impossible. You would have needed a supercomputer and months, literally months, of processing time. But then,
That processing time just collapsed. Thanks to GPUs and cloud computing, jobs that took months could now get done in just a few days. And the key takeaway here is that this incredible speed unlocked rapid-fire experimentation. It let researchers build, test, and tweak much more powerful models at a pace that was just unthinkable before.
All right, so we've got the data and we've got the power. The final piece of the puzzle was building the AI models themselves, the brains, the architectures that could actually learn to understand the super complex language and images of medicine.
And it turned out you needed different tools for different jobs. So you had convolutional neural networks, or CNNs, which became absolute pros at seeing patterns in images, perfect for radiology. Then you had recurrent neural networks, or RNNs, which were great at understanding things in sequence, like a patient's story over time. And now, of course, you have transformers, the engine behind large language models, which have mastered clinical text.
these smarter architectures, especially transformers, unlock something totally new: generative AI. This is where AI stops just analyzing or sorting information and starts to actually create brand new, coherent stuff, like text or even images, all based on the patterns it's learned.
So what does that actually look like? Well, it means an AI can digest pages of messy notes from a hospital stay and, boom, create a perfect, clean summary for the family doctor. It can scan clinical notes and flag potential diagnoses that a busy doctor might have overlooked. It can even create fake but totally realistic medical images to help train other AIs, which is a huge deal for studying rare diseases where you just don't have a lot of data.
But here's the thing. None of these amazing technologies would mean anything if they were just stuck in a research lab somewhere. For AI to really make a difference, it has to be woven directly into the tools that doctors and nurses are already using every single day.
This is where the, let's call it the less glamorous but absolutely essential work of interoperability comes in. You can think of it like creating a universal translator for all the different software in a hospital. These technical standards, with names like HL7 and FHIR, let all the different systems and AI tools finally speak the same language.
And when that integration works, you feel the impact everywhere. A doctor might see an AI-generated risk score pop up right in a patient's chart. A nurse might get a quiet alert on their dashboard saying, "Hey, keep an eye on the patient in room 302. Even hospital administrators can use AI to figure out the best staffing schedules. It just makes everything run smoother.
Okay, so if generative AI can create content, what's the next big step? The next frontier is something people are calling agentic AI. And this is where AI shifts from just being a creator to being an active, helpful assistant.
The difference here is really important. A generative AI makes a suggestion for a human to look at. An agentic AI can take that suggestion and start doing the next logical steps all by itself. It doesn't just give you an answer, it starts a process, linking tasks together and talking to other systems.
Let's make this real. An AI scans a chest X-ray and flags a little spot that looks unusual. That's step one. But an agentic system doesn't stop there. It then dives into the patient's record to see if there are risk factors, like a history of smoking. Then, it takes action. It drafts up a referral note to a lung specialist with all the relevant info, all ready for the doctor to just review and click send. It does all the tedious prep work.
And this is maybe the most important point of all. The goal here is not to replace human experts. It's to build a powerful assistant that takes care of the administrative busywork and helps connect the dots. This frees up clinicians to do what only they can do. Make complex judgments and, actually care for their patients. It's all about extending their reach.
Which, of course, brings us to a really fascinating final question. As these AI assistants get better and better at handling routine analysis and paperwork, how is the role of the human expert going to change? What's the new #1 skill for the doctors of the future? It's a huge question to think about as this technology continues to reshape medicine. Thanks for tuning in to This Explainer.